In today's video, we're going to go over a question I received over on LinkedIn, and it's really, can you go over some common SQL database performance mistakes and how to address them across platforms if there are differences? So let's dig in. So the first one I want to go over are missing indexes. So this is when you're querying a table, it could be large, and you've got a where clause, and it's not serviced by any indexes on the table. And so what happens is the database has no other choice but to do a full table scan, which is equivalent to paging through every page of a book. And so that can add up if you've got a large table. The other thing it can manifest in is slow joins and high I/O. So how do I address this and how do I look for it? So in SQL Server, there is actually a view that you can query, a DMV named sys.dm underscore db underscore missing underscore index and then underscore, and then there's several views under there. But what you can do is query that, and it'll tell you what queries in your system or what tables in your system are missing indexes on them based on queries that have been submitted to the database engine. And so what you can do is you can create indexes or something called a covered indexes, which is a special index that includes like all the columns in a select list in addition to columns that are in a where clause. And it really is a strategic thing when you create indexes that the order of the columns in the indexes really matter. And in general, you want to choose columns in your tables that have very high level of selectivity at the beginning end of the index. So I'm not going to go into too much detail now. I just want to mention that it does matter the order of the columns in the index. In Oracle, you can use the explain to look at the query plan that the database engine generates, and you can also use other tools like AWR, SQL Tuning Advisory, and the DBMS SQL Tune package. Postgres similarly has explain, analyze, and you can check the pgstat user indexes view to analyze what's going on in your engine. And in mySQL, again, they have an explain, and you can also enable something called the slow query log in mySQL to find cases where you may be missing indexes. Next up is overusing select star. So select star is when you select in a shorthand notation every column from your table. And what happens is if you have a large table that has a lot of rows and a lot of columns, you're going to waste a lot of network I/O selecting all these columns you don't need. And it also wastes memory. And something you can do, just a quick tip, is you can select the column names out of your system tables in order to generate a listing and then pick and choose what you want out of there. So we also want to avoid non-SARGable queries. This is really cases where you've got search arguments in your query that you can't use an index for. There's a couple of reasons for that. So one case is when you've got like a leading wildcard on a text. So you're doing a comparison and you're trying to look like, I see a lot of cases where people are looking like for the tail end of an email address and they put a % and then at yahoo.com or something like that. But it can't use an index in that case. So you're really not helping yourself too much. You are filtering the data, but you really are going to affect performance by not being able to use an index. The other case is when you're using functions around possibly columns that you think are indexed, but since you're wrapping it in a function call, it's not able to use the index. Now there are function-based indexes, but you're not always using them, and they're not as efficient as a normal B-tree type index on a column. So here's a couple of examples down here. I've got this order date and it's wrapped in a year function. You can convert that to something like where order date is in a range. So in this case, we're looking for everything at greater than or equal to January 1st, 2023 and less than 2024 January 1st. And that will allow you to use an index on order date. And the other case, like I said, if you've got like a % before a search term on a varchar type column, you want to avoid that if possible because you're not going to be able to use an index on that. Another common issue I see are outdated statistics. So all databases have ways of collecting statistics, and statistics allow the database query optimizer to generate efficient plans. So anytime you issue a query to a database, it's going to take that query and it's going to look for a plan if it already has one in its cache, and execute using that plan, or it's going to generate a plan. And the way it generates a plan is by looking at the statistics and look at the various columns that are in the where clause of the query, and try and figure out, well, let's say it's like querying from an employee table and looking for employees that are in a particular department. And so it would look at that department column and look at its statistics and see, hey, is that a very highly selective column, and do I have an index on it? And it's going to generate a plan based on it. And all the plan is figuring out what it thinks the most efficient path to getting data is. And it looks at all the tools it has, including like indexes on the table or what the various statistics we have. It puts together a plan on going at how it's going to query the data out of the database. If you're going to use a particular index on the query, or does it want to use an index scan, or in some cases it actually generates something where a table scan is the most efficient option based on the information it has at hand. And so if you looked at the various platforms, SQL Server has an update statistics command, and it actually has auto update statistics that you can enable. Oracle has the DBMS stats package to gather stats regularly. So you want to do is schedule these things in jobs. In SQL Server, you've got your agent. You want to schedule these things to be happening on a regular basis. And you want to have them scheduled at times of the day where it's not going to impact the overall performance if possible. Postgres has the analyze command and the auto vacuum for tuning. And mySQL also has an analyze command. Next we've got here is not monitoring your execution plans. If possible, you want to be trapping execution plans periodically, dumping them to a log. And you also really want to, as you're developing new SQL code, you should be generating the execution plan and analyzing that, making sure it makes sense, making sure that it's optimized and performant. And that'll go a long way. You don't want to be finding these things when your production system is slow. You're going to be under the gun, dealing with a lot of stress. Do it in development before it goes out. Trust me, it's the way to go. Next up here, we've got improper use of temp tables or CTEs. And the symptoms here, you're going to be spilling a lot of data to disk and unnecessary recomputations. And what's the fix? Well, in SQL Server, large temp tables can actually benefit. You can index them. So if you've got a stored procedure where you're utilizing a temp table, see if making an index on the temp table makes sense. In Postgres and Oracle, there's materialized views can be used. So you can materialize these CTEs and temp tables that you've got if reuse is going to be needed. And in mySQL, you can roll your own materialized view. All the materialized view really is a physical table that stores data. And it's a case that's, some cases it's transient, or in some cases it's like a snapshot based. So that's just the table underneath the covers. Having the ability to create them does make things easier, but you can always do it with your own tables. Next here we've got too many cursors or loops instead of using set logic. So if you're developing like stored procedures and you're creating a cursor and iterating over hundreds of thousands or millions of rows, in some cases you want to look and see if you can just do that with a set operation. So instead of like looping over a million rows, write an update statement that updates those particular rows, and so it might take a little more time to figure out exactly how to write that statement, but it goes a long way over having that very slow store procedure code that's iterating over that. They call it row by agonizing row, or RBAR. That's an acronym they use for that type of logic that you want to try and avoid. A very common issue is blocking and lock contention. I see it all the time. And this was, the symptoms are long waits and timeouts when you've got SQL running. And the fix is to try and use proper isolation levels. So in SQL Server, the default isolation level is an issue. And so You have to enable something called recommitted snapshot to sort of alter that behavior. Otherwise, readers block readers, writers block readers. Everyone's blocking each other in SQL Server in the default isolation levels. In Oracle, they use something called MVCC, multi-version concurrency control, and so we really need to change the isolation levels with Oracle, and the same is true with Postgres. Now, in MySQL, the storage engine is actually very important. The default, my ISAM does not support row level locking, and so you have to use something called InnoDB storage engine in order to have row level locking in MySQL. And that really relieves a lot of lock contention if you're able to have that. All these other databases, SQL Server, Oracle, and Postgres already support row level locking by default. All right, ninth here we've got bad or suboptimal joins. And the symptoms are going to be slow queries with nested loop joins on large tables. And the fix, again, is to understand those execution plans. So what you want to do is, let's say that you're using like a CTE or some sort of like a pseudo table or intermittent table in your query. You want to do the filtering as soon as possible. So if you've got like a CTE at the beginning of your query and it can filter some of the rows out of a large table, I would suggest doing that. And you can see this in when you're looking at the execution plan and seeing how it's going about the queries and seeing which tables it's addressing first and where those filters are being applied. You can also use things like hints, which are kind of an advanced topic, but you can use those inside your queries. Those are very specific to the platform that you're on. But again, they can tell the optimizer, hey, use this index or go and query this table first or something like that. And something that, at least in the past, it's not as prevalent now, is looking at the order of the tables in your query in your joins. So if you're querying, like if you've got physically in your table, you've got a table that appears first. In some cases that will influence the optimizer and it'll try to lean towards accessing that table first. And sometimes just something as simple as reordering the joins can have an effect on the query plan. And you look at that mostly these days probably in MySQL, but I have seen it in the past with the SQL Server and Oracle, how it influences the optimizer. And last but not least, number 10 on our list here is poor parameter sniffing or hard-coded literals in your query. So the symptoms you're going to have here are your plans are not going to be optimal for varying inputs into them. So, and what I'm talking about with hard-coded literals, so an example down here, let's say I have a query, select name, address from employee, where department equals HR. So this is a hard-coded literal string inside your query. And what you can do is parameterize that. And so in this case, we're passing in a parameter for the department. And so we can sort of template this query and we can generate a generic plan for it. And then we can pass in various values instead of, let's say I have like 100,000 different departments or something crazy like that. If I'm passing each one of those as hard-coded literals, those are going to all need their own execution plan in the cache. So you would have an entry in your cache for each and every one of them, which could bloat the cache. Here in this case, we're only generating one plan. It's generic for them. And sometimes that's a problem though, because I might have like only like 10 employees in a department and maybe 100,000 in another. And that's going to have a dramatic effect on the plan that could be used. And so you might want to tell the database engine, hey, I don't want to optimize this up front. I want to optimize it when the actual value gets passed in. And in that case, it could have like go and generate a plan specific for that particular department in that case. And so you would use things like optimize for, recompile. And these, like I said, these are called bind variables in Oracle when you're using parameterized values. In Postgres, you would use like a prepare statement inside your code to avoid the literal value of every different case that comes in. Same thing with mySQL, you would use parameterized queries. And that'll do it for today. I appreciate you guys watching. Hey, if there's something I missed, please let me know. I'd love to know. Drop it in the comments. And of course, please like, follow, subscribe, and share the content with your network. Thanks. Bye.